Want to use it then?
Last week.
Do I understand the definition of a logarithm? And I'm just going to write log. And I do this little curly L because first block out my L's just look like parentheses, so people are like, "What's this OG thing?"
Are we original gangsters?
I know, right? Do I understand the definition of a logarithm? And just know that log means logarithm. I'm not ever going to write logarithm out anymore. It's silly to do that.
You know, have you ever written out logarithm?
Yeah, duh. Of course. I know how to spell. Logarithm. Don't question me. Yeah, I know how to spell.
Hey, look, it's just a right below.
I'm tempted to put a Y in logarithm. Alright. And then can I, guys, do I understand the definition? And can I graph log functions and, well, we'll see this. Graph log functions and state, and this stays the same. State, domain, range, and asymptotes. Okay, so that'll all stay the same. Actually, graphing logs isn't too bad. Partially because so much of it is what we've already built on. It's just, this big one here is, do I understand the definition of a logarithm? We'll be fine. So a logarithm with base b. Maybe you've seen this before, but when I write a logarithm out, I say log. It has a base b, and that b is a little subscript, right? Little bitty thing underneath it. It'll be a number or an exponent usually, but it's that base b. So b stays the same. We use b for base and exponential growth and decay. I'm going to use b for base and logarithm. Okay? So log base b of y. When we do that, we say it equals a number, all right? So I say log base b of y equals x. So if I wanted to write that out, log of, no, not log of, log base b of y is x. All right, so if I was going to write this out, the math, if I was going to write it out in words, I'd say log base b of y is x. So all of our variables are all in one big thing, right? All three of them. So what do they all mean? All right, so let's look at it mathematically. Rewrite a logarithm in exponential form. We'll need to be able to go back and forth between logarithmic form and exponential form. Back and forth between the two. Yeah. Well, just wait. But it's a mathematical definition. So hold on, we'll get there. So rewrite a logarithm in exponential form. This will help clear up the definition. I know I didn't expect that to make it click. So what I'm doing with a logarithm, right? So if I have log b of y equals x, if I want to change that to exponential form, okay? I take b. B is still my base, so that stays the same if I'm going to change it to an exponent. B is still my base. And I'm saying b up to x equals y. So that's where my three variables go back and forth. I got b, y, and x. Look where they are in a logarithm. Base b log y equals x. B to the x equals y. That's just going back and forth. So what a logarithm is asking me, for example, rewrite each logarithm in exponential form, and I'm, yeah. Yes, the log goes away. Yeah. There's gonna, guys, you're gonna have a lot of questions. Where did this go? Where's that? Stay with me. We're gonna have plenty of time for questions. We'll be fine. Don't worry. I'm totally fine if you want to write this out with words. So what this is asking me, what the word log, what the function log means, it's actually asking me to the third power, we'll say third, 2 to the third power, or 2 cubed, right, equals 8. So writing this, there's my b, my base is 2, my y is 8, and my x is 3. So if I'm going to change this to this, my base is 2. What am I raised to? 3, because that's my x, right? So that's everything that's on that side, right? And that equals 8. That would be your answer there in exponential form, right? I've taken this statement. This is an equation, but I'm not asking you to solve, right? Log base 2 of 8 equals 3. I'm taking that statement, which is a true statement, and I'm changing it to exponential form.
Is it okay to change something if it's an untrue statement as well?
No, but if I wouldn't give you.
Okay.
No, I mean you can change it and put it in. That might say, hey, is this true? We'll put it in exponential form and find out if it is. But I don't think I have any questions.
This is hard, not hard.
No, this is, and actually, guys, this is the definition of a logarithm. Not bad. All right, like let's keep going. Make sure we solidify it. The frustration comes. All right. So this next one, if you wanted to write out, 4 to the 0 power equals 1, you could. Or this is just saying base 4. Your base of your log will always be your base of your exponent, raised to the 0 power equals 1. And that's true. Anything raised to the 0 power is 1, right? Cool. Why do we even have this? Why don't we just deal with exponents? Just a little. Why did they just start with this? This is just getting us a definition. This isn't really how we'll use logs. It's pretty close, but you'll see. All right, so log base 12, right, to the first power equals 12. That makes sense. Anytime you have a log and the base is the same as that x right there, the answer is going to be 1, because anything with the first power is itself, right? And then negative ones are very strange, right? This is saying my base is 1/4. I'm raising it to the negative first power, and that should get me 4. We all see how that works? If I'm taking a negative 1 to 1/4, I get rid of that negative exponent by flipping 1/4, so 4 over 1. Cool? So evaluating logarithms. This is more, guys, where we start doing math with logs. That's just to get the definition. So notice there's no equal signs here. We're missing those, right? Evaluate the logarithm. So log base 4 of 64. So this is asking me 4 to what power equals 64. So what do I have to raise 4 to get 64? 4 times 16 is 64, but what power do I want to raise 4 to? 4 to the third, right? So 4 times 4 is 16, that's squared. And then times 4 again, that's cubed, is 64. So these would be, guys, evaluations without a calculator. Never going to throw anything like log base 7 of 14,392 and tell you to do it without a calculator. That'd be mean. And you didn't know that 7 to the 4th power is. No, I'm not going to do it. I don't even know if that's right. Never going to do anything like that. But evaluating logs without a calculator, you should be able to do for most basic squares and cubes, right? This would be the furthest I'd put you. Just
I'll do the 2,401.
Okay. So the answer for this, guys, would just be 3. If I'm going to evaluate that logarithm, it's just an answer of 3. 4 to the third power. All right. So writing this out, 5 to what power equals 0.2. That one's tougher. If you wanted to set it up like this, guys, really, you're looking for kind of like an x, right? You're looking for an unknown, like a variable. So what power am I looking for? If you wanted to change this and say, all right, 5 to what power? So 5 to, and I'll just put a question mark, equals 0.2, and then use that to evaluate, to find my unknown riddle. That'd be fine. Lucky,
Five to the negative 1.
so -1. How did you know?
I guessed.
You
Oh,
guessed?
that's right.
Let's change, guys. Let's change 0.2 to a fraction. So I still have my little question mark. What am I going to change 0.2 to? 1/5, right? So how do I get 5 to 1 over 5? What power do I raise it to? -1, right? If I raise 5 to the negative first power, I just flip it and get the reciprocal. So my answer there, -1. On super simple, just evaluate logs, either with or without your calculator. And usually just one number.
Wait, how did you got the reciprocal of fraction?
Right, so 5 to what power is 1/5? Well, if I do -1, 5 to the negative first, that's equal to 1 over 5 to the first, which is just 1/5. Right, so that's how I get from 5 to -1. If you want to think about it like, I've got this number, and I want to get to this number, but I can only use exponents. That's fine, because that's how a log works. Good, last one, do on your own. Go, go, go. If you've already done it, I'll sign it. On your own, on your own.
I don't like it.
Really? Who's first?
9 to the 9, 9 to the 3rd. So 1, 2, 3. What a jack. I'm sorry, I thought it was a 9.
Keep trying. Good. You always rush your back. Oh, good. So what's your answer? Circle your answer. You haven't evaluated this. What about circling? Or the box. The box with 3. The box with 1. So the exponent of raising 3 is what? You're right.
Easy part. 2. Oh, I'll help you. Okay.
Okay, that's fine.
What? Okay, what?
My right too far?
What is it? What is
Two, right? 3 squared, 3 to the second power is 9. All right, Trent, back with me. Let's go. So you will recall that when we were using E last. Oh. Zoom out. Zoom out. Remember last time? Guys, seriously, I know right now is easy. Wait. No. Remember last time when we were looking for E, and we just needed E raised to the X, and they said it's this ln button, but it's the second function, right? Then we're going to use that natural log button now. You've got you have 3 kinds of logarithms. You have a common logarithm. You have just, I guess, standard logarithms that aren't common logarithms.
Natural?
And then you have natural logarithms, all right? So that's what ln means. All right, is natural log. Let me get through this and we'll get to that. A common logarithm, all right, is when I have any log that is base 10. Okay? So if my b has a base of is equal to 10, that is called a common log. So we haven't seen any of those. I've had log 3, log base 5, log base 4. Those aren't common logs. Look on your calculator, all right, and the log button. If I hit the log button, Notice that it doesn't tell me what my base is.
Catalogs.
Yeah.
Notice, so you don't, on your calculator, you don't see a base, right? Your calculators, all of them, have a default setting to use common log. So what is the base on this log? 10. So if I do common log of 10, what should I get? 1, right? Because 10 to the first is 10. So your calculator, if you just hit the log button, will give you a common log. It's going to do base 10 automatically. On any worksheet or any quiz or test or bookwork you do, if you see the word log and then without a base, it doesn't give you it, it's log base 10. That's a common log. Natural log, then, okay, here. So really, log base 10 of y, but they're not going to give you that. They're just going to say log of y, and you have to assume that 10 is there. And it is there. There's no tricks. You use it a lot for scientific notation. So times 10 to the exponent. So this log base 10 is very common in that, so they call it the common log. That was its first function. I know, a little bit. Natural log, so ln, right, and we have a y, similarly will not give you a base. It's not going to show you what the base is. But anytime you see ln, what do you think the base is? Any guesses?
1, 5.
1, 5. What did we talk about? Was that natural number?
It's like 2.
E, 2.72. So natural logs have a base of e. Again, your calculator isn't going to show that to you. They're not going to write that on any worksheets or anything. I'm not going to do natural log base e. No, natural log means a log with base e. It's the only thing that's different. Is for some reason with e, we get a very specific log, and you treat them the exact same way. Everything's exactly the same, but it gets its own base e log. We call it natural log. Don't ask me why. I'm sure it's fascinating, but they won't give you this. It'll just be ln of 1. Okay, so those are your bases. So if I'm going to evaluate using a calculator, this is the same if you've got an 84, 83, and even an old school 82 plus, what I grew up on.
They're around.
I don't know. I doubt anyone has it. So, oh, sorry, I already forgot. Was it log base 8? The log of 8. It doesn't give you a base. So you can just type it in just like that. Nah, you guys probably can't see that at all.
I can't find the point. X double S.
Good. Enter. I got a 0.90. Goodness. It's 903. So I'm going to get 0.903.
You know, log is.
So
Go. Do we round this to like, just like the E?
wherever you.
Yeah.
I would round. If you put 0.90 here, I would take off. I see 0.903. I think give me that 3. It's a little more specific. Unless I tell you where to round, it's okay. Wherever you want. So the natural log of 0.3. Natural log ln 0.3. You get a negative 1.20. We'll just do negative 1.2. That's fine. Negative 1.2. And that makes sense. My base E is about 2.7. So changing that to a decimal 0.3, basically making it a fraction, I'm taking 1 over 2.7 raised to a decimal, or to an exponent. Cool? Oh no, the Casio strikes again. So finding inverses, you guys. I want to do this. I'm not going to ask you. Yeah, all right. 8 people on this list. That enough. I got like 3 people on this list.
I'm not helping.
All right. Find the inverse of the function. Trent, what's the first thing I always do when I want to find an inverse? Switch x and y. So x equals 4 to the y now. So how in the world am I going to get rid of x equals 4 to the y? How do I want to get y by itself, right? That's my second step. So switch x and y, resolve for y, that'll give me my inverse. Brent, any ideas? I want to get y by what? I already did that. That's how I got to here.
Uh,
I need to find the inverse. That's why I flipped. You would do that. Jameson?
I don't know. I'm taking a guess. Divide by 4.
And then divide by 4, I still have like an exponent, so this would be 1 up to y. And I still don't know what y is, so that doesn't get rid of it.
could you put 4 in like a negative x as the exponent, and take the inverse exponent of y?
Alright, so we're getting close. We're getting close. I don't want to, I'm sure we're getting closer, we're getting closer. I want to show you. Guys, if I said that using logs, we'll use them, right? Right now we're doing it to find an inverse, but ultimately we're solving for something, right? We will use logs to solve in logarithmic functions. The log is just another tool in your tool bag of just things to use when solving. It started off, with algebra, just adding and subtracting, right? Then we threw in some multiplication, division, and we started FOILing and factoring, using quadratic. We use all these tools to solve, right? This is just the latest one. So I'm going to take the log of both sides. I said I was going to use the cursive L.
Alright.
I'm going to take the log of both sides. So log of x equals log of 4 to the y. Now, I need to change my base to a very specific number in order for this to do anything. Otherwise, I'm just doing the log of both sides. It won't get me anywhere. Any ideas for what number my base will be? Not e, that would make it a natural log. 2.
Base would be y.
No, not y. Although you're onto something, you might both be onto something. Guys, ultimately I want to get y by itself. Well, this 4 is being raised to y. So if I take log base 4 of both sides, let's look at just the right. Log base 4 of 4 to y. If I was just going to solve that, okay, let's just take this side. Think about it for a while. That's base 4 up to what? We're looking for just a question mark equals 4 to y. So what's my question mark? What am I looking for?
X. That looks like a y.
That is a y.
It is.
Oh.
So why just say x?
You put you find y.
Right, so this is just, this whole expression here, guys, will simplify down to just y. So now I have log, I said I do curlies, log base 4 of x equals y. If you don't see that, so log base 4 of 4 to the y. So what 4 raised to what power equals 4 raised to y? Well, y.
This is kind of pulling my brain space down.
So the 4s they don't really cancel. I mean, yes, in a way, right? Guys, this is a rule of logs. Listen, anytime you have a log, and the base is the same as the, as our x, what we're looking for. So if anytime your base 4 is the same as the actual log you're taking 4. Right? Think back to this first guy here.
No.
Ashton, log base 12 of 12. Right? My base and my x were the same. So it just becomes 1. Right. And then it's just 1. Good. Yeah, they cancel, yes, but it's not, I mean, they go away. But it's not necessarily cancel, because canceling we usually mean like So, guys, so finding the inverse of y equals 4 to x, Ashton.
Wasn't even me.
Hold on, move over here.
Thank you.
Go. Now, guys, the inverse of an exponential function like this, x equals 4 to the y, the opposite of exponential functions, the inverse, are logarithmic functions. Cool? No?
Not really. I'm
Excuse me, do Amelia have?
I want to talk a little bit about parent functions. Oh, we'll worry about that later. I'm not too worried about that. Well, you do the same thing. We'll do B. We'll do B. I'll do B really quick. Here's the deal. I'm worried that doing B will Ashton. Yeah, I'm gonna skip it. Don't worry about it. You'll be fine. But the inverse is the reason we're going through inverses right there. We will deal. guys.
Will you at least write the answer for B? Just running in the block.
Yeah, I'll write the answer, yeah. The reason I'm dealing with inverses right now and using logs, we're not gonna get to this for a couple more days, actually tomorrow, things like that. But I wanted to get to graphing and have you see inverses. The answer to B is e to the x minus 3, my bad. Minus 3 equals 1. Real quick, the way I got to that, I switch x and y, I always do that, and the way I get rid of this natural log, to get rid of an exponent,
Excuse me.
yes. The big deal here was that logs and exponential functions are opposites. I've given you parent graphs. This is your basic parent graph for exponential growth, b to the x, right? Where b is greater than 1 jillion. This was my basic function for exponential decay, where b was between 0 and 1. And then flipped over y equals x, I've got the inverses. So this is log base b of x, and this is log base b of x. But both of them are, one's for exponential decay, one's for exponential.
Which one's for decay?
One on the right. Because b is between 0 and 1. Not too worried about that. Probably should have cut it out. I'm drawing myself, but it is what it is. So, graphing. Graph the function, state the domain, range, and asymptote. So we've seen this before. The only thing new is logs. But we're going to do the same things we did on the last page here. So I've got log base 3 of x equals y. So 3 raised to some power equals a number. So what's the first thing I always do when I'm graphing?
Make it 0.
Make a table.
Oh, well, I thought the table was just common knowledge at this point.
No.
And then x is 0. Here.
So, guys, what I used to do here, I used to plug in x's, and we'd use like -2 up to 2, right? So -2, -1, 0. If I plug in, let's say -2, all right, for x, so then I have y equals log base 3 of -2. So what power makes 3 to -2? Without a calculator. You can't do that. And that's fine. I'm not going to show you how to do that. So you don't actually plug in numbers for x. What if I flipped this, guys? What if I said, what if I used -2, -1, 0, 1, and 2? What if I used them on the other side? What if it was y? What if -2 equals log base 3 of x? What is this then asking me? Solve for x, but put this into exponential form. So base 3 raised to the -2 power equals x. So what is x?
1/9.
I see what first block was saying, where your L's in like parentheses.
Dang it. Yeah, I know. So I do curly. Yeah, much better, right?
Yeah.
And I feel fancy. So x equals 1/9, right? Because this is 1 over 3 squared, which is 1 over 9. So for for graphing logarithmic functions, you're not going to plug in x's, you're going to plug in y's. So -2, -1, 0, 1, and 2. So I already know if I plug in -2, I've got a 1/9. Okay? If I plug in -1, what am I going to get? So -1 equals log base 3 of x. What is x?
1/9.
I got a 1/9. Anything else? Anybody second that? Anybody disagree? Anybody get anything different? Rewrite it. Rewrite -1 equals log base 3 of x in exponential form. I'm hearing some 1/3, right? This is asking me x equals 3 up to the -1st power. Right? So x equals 1/3. Good. 0? Correction? Oh, good. 1. Anything raised to a 0 power is 1, guys. Anything. 1, 3, and 9.
Yeah.
That's it. Now I'm just going to graph. All right, so let's get up here and graph this. I've got, and don't, here's where a lot of people switched it up. We plugged in y and got x. That doesn't mean my x and y values are switched. I need to still go 9 and 2, right? So 9x, y 2, 3 and 1, right? 1 and 0, 1/3 and -1, and 1/9 and -2. So, where is my asymptote here?
You should actually take 2 steps that way.
Y equals 0.
Y equals 0. So, Lucky's saying that it's y equals 0. Wait a minute.
Oh wait, x equals 0. I mean.
Yeah.
Wait, no, I did mean y equals 0.
Y equals 0?
Yeah, not x.
Y equals 0 is the x-axis.
Oh, okay, my bad. I meant y is 0.
That's not it. Okay. Draw this back because Lucky gave me the wrong answer. Anybody else? It's not a horizontal asymptote. So it has to be
X is 0.
It has to be a vertical asymptote, which means it's x equals something. So x equals 0, you guys. So for exponential functions, I had horizontal asymptotes. And when I started dealing with h and k, which we'll do next, that moved my asymptote up and down, right? With logarithmic functions, I have vertical asymptotes. It's the inverse, so it's a vertical asymptote, right? So my asymptote would be x equals the number. So, domain and range on this. How about domain? I'm hearing all real numbers. So like negative, it's switched, right? So on again, yeah, exponential, I was having y equals for my range. It had to be above or below something. Alex, what's my new domain? X less than? Greater than, right? I'm going to the right this way, so x is greater than 0. Like
What would a parent function of a logarithm graph look like?
that right there.
For decay and
Your red is logs, and to the right is decay, and to the left is growth. Okay, those are your parent functions. So this is growth, and I didn't talk about this too much, guys. If the growth and decay stay the same, if b is greater than 1, I have growth. Up. Oh, down. Well, hold on. Let me finish this. I'm going to go back down. We're going to do more work there. So, thanks for not interrupting me now. I know. If b is greater than 1, I have growth. And here's the parent function for growth, if b is greater than 1. If b is less than 1, just like exponential decay, I have logarithmic decay. Okay? So this first one we could have looked at and told me, yeah, that's growth. b, my base, 3, is greater than 1. How about this next one?
decay.
Decay. Good. So let's make a chart. Oh, we didn't finish range.
Yeah, I'm saying
Range,
All numbers.
all real numbers, right? I'm going up and down my y for both. Good. And I already know I have a vertical asymptote, right, at x equals 0. On your own, do the next one. Make a chart. Do -2 up to 2 for not x, but y. So plug in those. You can feel free to change it to what do you call it? Exponential form. Give me a graph with asymptotes and everything on your own. Come back. Come back to me.
that's why I said
Keep working and or listen. That's fine. So, some people are asking, Why do I plug in numbers for y? Why do I know that I'm plugging in -2 up to 2? The reason I'm choosing those numbers, right? Ultimately, I can either choose numbers for x and solve for y. So that means picking some really weird numbers and being able to basically do pretty complex calculations in my head. Or I can say, you know what? My y here is just an exponent. So if I'm just raising my base to an exponent, well, I want to choose what numbers I'm raising by. If I'm raising to exponents, I'm going to raise to 0, because I always know I'm going to get 1. All right? And then I'm going to do 1, because anything raised to 1 is just itself. And then I need some more points, so let's just do squared. And then the negative versions of that. On some of your homework, you'll only have space for 3 places. We'll do 0, because you'll get 1. And then just be like 1 and -1, or squared and negative squared. Yeah. Vertical asymptotes. We can HA for horizontal, CA for vertical. Because a vertical one is an x value, right? For straight lines. Horizontal, we say y equals vertical x equals. How?
So in terms of range, would it be negative or less?
Yes, but you'll actually never have.
Okay.
Yes, you're right. But
So the log, it's always going to be greater than.
good question. No. Good. So let's graph this sucker. 4 and -2. 2 and -1, 1 and 0, 1/2 and 1, and 1/4 and 2. Good, so I'm clearly coming from up here, sliding on down to there. Vertical asymptote unchanged.
It won't
So-
change unless, is there an H and K?
Yes, that's next. Good question. That's next. Good. Domain on this. X has to be greater than 0, right? I'm all my numbers to the right of the y-axis. Range, all real numbers, good. And I know that I have a vertical asymptote at x equals 0. Good, so Lucky just segued us to very nice. Nicely, that should be an adverb. Into translations. Translations are actually pretty easy. They're almost identical to what you just did, H and K and everything else. So for my translations, my whole form is y equals A. That's my coefficient. A will stretch me, make me skinnier and things like that. I'm less concerned about that and more with positive and negative. Because what do you think a negative A will do to my log function?
It'll switch it over X.
Yeah, I'll flip it over the x-axis, just like I did with exponential and really anything, right? So a negative a value will flip me, so we'll pay attention to that. And then we just have log base b. All right, and here's where my h is. Notice that it's still minus h, so when I'm going horizontally and moving left and right, I still change the sign. So if I want to move to the left, I want a positive number, and vice versa. Plus k. And so k just still moves me up or down. Before, on exponential, we were really worried about k, because I had a horizontal asymptote, and like a +3 would move my asymptote up 3, right? A -5 would move it down 5. Now I'm more concerned with h, because I have a vertical asymptote, which means it moves left and right, right? Right, left. Yeah, so fun. Go on. No,
Well, it's hard to be fun when you're done. Hey, at least we're not talking.
what?
We don't know what's going on.
Fair enough.
Yeah.
No, that's,
You're right.
Hey, to make it even better, half the class is
I know, I love that. It's great that it's all over. All right, so H, or sorry,
See that? No.
A, guys, A will,
It's back.
folks, A will stretch, but more importantly, it can flip.
Why is flipping more important than stretching?
Well, because on a lot of like sketches, for example, yeah. Okay, you'll be all right. Yeah, you should be fine. You got most of it.
But
We'll catch up. Don't worry. When I'm like sketching, Christian, most important, like, it's gonna be hard without points when I'm asking you to sketch to get like an exact. Sorry, to get a I can't think right now. There's just too much going on. It'll be hard to get an exact curve going, but you can show me where the asymptote is, right? So, and you can show me that I'm flipped over the right side of the axis. So A will stretch and flip me. H moves horizontally still, so left and right. And K moves up or down. Stays the same, guys. So, graph the function, state the domain, range, and asymptote. All the same stuff, right? Only thing that's different, well, I'm still got a log base, but I'm throwing an H term in. Okay? So looking at this first one, A, how is it going to move? Left, right, up, or down?
A? It's gonna.
For A.
Wait, what do you mean up and down?
Which way is it going to move?
Oh, it's gonna move right 3.
I'm seeing right to the right 3, right? So I changed the sign, plus 3. So I already know, I'm just going to go ahead and graph it where my asymptote is, right? It's at
Right
x
3.
equals 3.
Does moving it up and down change the asymptote at all?
No, not here. Well, I don't have a negative though. Oh, you mean on here, on H. Yeah, that stays the same, right? That's just like I did with even like vertex form for parabolas, but also x equals 3. Yes, good. You're good. Good. So let's make a chart, guys. X and Y, right? Same thing. Plug in -2s, -1, 0, 1, and 2. So if I, this would be definitely a calculator problem, okay? Because once you get into this, you'll see why. So set this up, log base 1/3, x minus 3. Well, I'm going to plug in a -2 here. So -2 equals log base 1/3.
Wait, is it okay if you just substitute it into the, like, 1/3 to the -2 equals parentheses x
Yeah,
minus
well
3?
then, and then the next step here you're saying is 1/3 to -2 equals
Yeah.
x minus 3. Yes.
And then
Yeah.
can you just add the 3 over and then solve?
No, you can't add the 3 and then solve.
Wait,
Well, if you wanted to do this and then add 3, that's fine. Or I could take this. This is what, 9? So 1/3 negative, right? So it's 3, and then 3 squared is 9. Equals x minus 3, so x equals 12.
Wow.
Yeah, there's a little more math here. You got to do that x minus 3 at the end, right? So it equals 12. So I plugged in -2 and got 12. All right, -1. If you want, guys, every time you can just go back here and change this to -1 now. Okay, so 1/3 to the negative first is 3. 3 plus 3 is 6 equals. Okay. And I'd be fine with a calculator. This is kind of easy math you can do in your head, but sometimes I'll throw, like these could be a little more difficult, I'll admit.
Is this called deriving an equation if you're going to get the 3 over for x? What is deriving an equation?
Deriving,
Yeah.
it's a whole. Not always.
No.
We do a lot of deriving in trig.
Is it when there's just a
It's
bunch
not,
of
it's not
like,
hard.
a bunch of different variables and letters and something, and you have to change everything around for one letter?
No.
Well,
Well,
yes, too bad.
I want to talk about it later. Keep going. So you plug in 0, you get 1, 1 plus 3. Oh, it's not 5, it's, yeah, it's 4.
Oh, yeah.
Jackson graph basic math. Good. Plug in 1. This is where you probably want a calculator because you'll get some decimals.
Yeah.
So 1/3 to the first is what, Lucky?
Something about, let's see.
Trent, what do I get for 1?
So plug in 1. I have no idea.
3 and 1/3.
1 plus, or 1/3 plus 3, right? So do that, 1/3 plus 3, and give me a decimal. What is it?
3.3.
3.33 is good. All right, let's do 2. 1/3 squared is 1/9, right?
Plus 3.
Plus 3.
3 point.
3.11, yeah, that'll work. Good, so let's graph that. 12, I don't really have, if you wanted to give yourself a point, that's fine, but basically down here. 6, 1, 2, 3, 4, 5, 6, and negative 1. 4 and 0. Yeah. 3.33 and 1. 1, 1, 1, and 2. Good, so now I can see what's going on here. I lost my point over there. Cool. Yeah.
Your 4 inches not bad.
It's not that bad once you figure this out, and I should have shown you this. My bad. So what this is saying, so if I plug in the negative, let's do negative 1. Negative 1 equals log base 4, so I'd do curlies, x plus 1 minus 2, right? There's a 1 there. All right. Before I can change this to my 4 to the negative 1 equals x plus 1, right? If I pretended that wasn't there, because that's what I did up here. Before I, what? Before I do that, I need to get rid of this negative 2. So I'm going to add 2 to both sides. Right, so 1 equals log base 4. No, it's 1. So the numbers you plugged in have changed. And if you wanted to plug in different numbers, but I would still do negative 2 up to 2. So hold on. So now I'm saying 4 raised to the first equals x plus 1, right? It's 4 to what power equals x plus 1? I know this 1, right? So 4 equals x plus 1, so x equals 3. So I plug in negative 1, I get 3. I already did negative 2 and got 0. Right. So before you do any of this logging, the switching to an exponential form, you've got to make sure there's nothing else on that log side, right? It's PLMDOS. It's like we had it. It's not actually PLMDOS. It doesn't fit. It should be.
Should be like
That makes
pound
sense?
dots
Okay.
or something.